Hey, thanks everybody. Thank you for coming. I'm going to do something a little different this year. In the past, I've done a lot of State of the Union with KiCad. This year, I'm just going to ask you if you want to keep track of what's going on with KiCad. Go out and look at the version 6 roadmap. Works in progress now, so we've been working on that. I want to talk a little bit about, I've been kind of musing in my mind about how KiCad's role has helped the open hardware movement and where we're going with that. And in order to do that, we've got to go all the way back to the beginning of the open source software movement and see how that progressed. And I think what you'll notice is, I look around and I don't see a lot of people in this room older than I am, so there's probably a lot of you won't remember, or some of us, where we started with the open source software movement. You're going to see a lot of similarities in the open source hardware movement, even though it's much earlier stage of that. So in the beginning, before there was anything that resembled a personal computer, people worked on mainframes and everybody sat in terminals and it was connected to the mainframe, and the only time you worked on software was when you were connected to that mainframe. So software development back then was the only people that worked on software collaboratively were people who either worked for the government, universities, or large corporations like IBM. But it was pretty obvious even back then in the very early days of computing that software copyrights were coming. So the big companies lobbied the major governments. In 1964, software copyrights were recognized in the US, and pretty much everybody else the rest of the world followed suit pretty quickly, okay? So there was kind of a lull there while they were still sorting out the microprocessor world. So the small 8-bit micros that were in design between the early 60s into the early to mid 70s, it took a while. So there wasn't really any software development open to what you would call the general public, right? By the end of the 70s, the PC was starting to take root. So these startup companies of Apple and the IBM released their PC in this area, right? So really early in this movement, only enthusiasts went out and bought computers for personal use, right? Nobody else had them. They weren't on everybody's desktop. Now they're in everybody's pocket. So there was a lot of sharing of code early on. People would say, hey, look at this thing I made, and there would be like these conferences like this where people who were writing software for computers would meet up and share ideas. But it didn't last very long because this grew so fast that people realized that, well, there's money. There's not just money to be made selling software for mainframes. There's money to be made for selling software on personal computers. So that ushered in the dark ages. Basically, once the sharing stopped, all the licenses went proprietary. There was no longer any concept of open source software at all. They were restrictive, proprietary. We've all seen those licenses before. They've been around for decades. Early on, even commercial software quality was not what it is. I mean, today, if you've never if you're never part of this and having to live with, because you lived with this, because software distribution was by some media, hard media, like there was no internet. It was either a floppy disk or some other, that was how software got distributed. So bugs persisted until you upgraded to the next version, right? So you had to buy the next version upgrade to get the bugs fixed, but then there was always some new bugs that came with the new features, right? Some of the things that also happened during this time that was not very nice was working applications were purposely broken for competitive advantage. I won't call anybody out, but if you know the history of that, you know who did those kinds of things. And basically, if you were a software user like I was during this time, you kind of felt like that you were just an afterthought. It didn't feel like they had your best interest at heart. So what happened is a large group of professional programmers were kind of getting frustrated with this whole idea of proprietary software. And so in 1980, the BSD released the first, what we now know as the first truly open source license, right? And MIT followed not long after that in the mid 80s. So most of this was done at the university level. Most of the open source software was done by educators and the staff, right? But there was a couple of big time projects during this period that were, because of the permissiveness of these licenses, there were two projects that to mind: BSD sockets and Kerberos. And they were hijacked, and then the point of those two projects was to unify things, right? We were going to bring everybody together, right? Well, they were broken for competitive advantage, and so a group of people realized that these licenses were not necessarily, the spirit of these licenses was always to make your code freely available, but it didn't specify that. So later in the 80s, the GNU project was formed, and they released the first version of the GPL, right? And so that opened up the foundation. So the GNU project worked on all the core tools, compilers, librarians. They basically had clean room versions of all the Unix tools that people had used back in the days, right? And what helped spur that was the internet, right? The early internet, even the good old dial-up days of 19.2K, and your phone line would scream at you when you logged on to it. It was a way for people to collaborate, and things started to grow pretty quickly at this point, okay? So now so we still lacked a kernel. So in 1991, some guy from Finland created a kernel under the GPL2, okay? And that really spurred development. Things really took off at this point. So within a couple of years, by the mid-90s, there were probably a dozen packaged distros of Linux. So you had Red Hat and Debian and Mandrake and SUSE. And so there was a whole bunch of them. So you didn't even need to do any compiling anymore. You could download, install, and run Linux. And this is when I got in. Oh, sorry. I like to move around. This is when I started getting involved in open source development. And at the same time, right around this same time, there's some guy, a professor named Jean-Pierre Chirac, that worked in a university in France, started working on a project called KiCad. Okay, so that's how old KiCad goes back to the very, very, just when the whole open source thing was really starting to take off. What really changed the tide was high-speed internet access. Once high-speed net access became readily available, the effective cost of distributing software went to zero, right? So now open source development was kind of in full swing at this point. By the late 2000s, the small form factor devices and smartphone industry, it was everywhere now. You couldn't hardly use a device without touching open source software. You may not have known that you were using it, but you were using it. So at this point, FLOSS won. There's not any debate here about whether or not FLOSS was the dominant development model for software, right? But also during this time, we started to see hardware design tools. KiCad projects even though it was always public, it was never really publicly developed, and that happened in the late 2000s. Groups of people started actually working on KiCad to collaborate and improve it. Okay. So also during this time, there was some move. So now we had some tools, and they weren't super powerful compared to the commercial hardware development tools, but we had them. So we were starting to see some growth in the idea of open hardware, because people wanted the same arguments for open source software you could almost make for open source open hardware. It's freely available, you can learn, you can extend it. There's lots of good reasons to do that, right? So what happened here was the CERN released their open hardware license in 2011, and they also joined the KiCad project, because one of their mandates is their intellectual property they want to be public, and they realized that if they were going to use a proprietary piece of software, well, how open was it? It technically, their hardware designs were open, practically less so. Okay, so that's why they joined and started to help make KiCad functional. So during this time, it's pretty obvious from some of the talks that open source design tools are increasing in power, usability. In some cases, they're approaching a lot of commercial products. So as you see, there's an interesting thing here that recently board vendors have been supporting KiCad board files directly. You don't have to go through the processing step of generating Gerbers and the way we've done it for 40 years now. So obviously we're having some influence there in the hardware space, because people would otherwise, because if there wasn't enough reason to do so, they wouldn't. So that's kind of where we are at the moment. So what also happening at the same time, which was really interesting, and I honestly didn't see that one coming, was RISC-V development. So we now have an open, in the last few years, RISC-V has been implemented by quite a few people. So this is an open, taped out part and a design for people to build upon, right? That, I think that's, I don't think you can undercut the significance of how important that is, because, you know, we're getting open we're getting open boards and open electronic circuits designs, but we really don't, there's still things we don't know about our electronics, right? That's all hidden from us. And if you, like in the past, the hardware was always kind of approached as, well, it's a black box. You just have to trust that it works. But given the last few years, like with things like Spectre and Meltdown, we now know that our black boxes might have problems. And so one of the things I'd like to see happen is die level development tools start to be opened and moved into like KiCad for development. So now, I'm not naive enough to believe that the hardware will quite be the same way as the software, because obviously the cost will never be zero for hardware. There's always going to be some cost involved. But one of the questions I have is, well, will the stack from top to bottom ever be fully open? And I don't see the reason why it can't be. I mean, there's going to be resistance, just like there was resistance to open source software back in when it was developed. So the only thing that's left is will the cost of that determine how the rate of open hardware? And you can see, like, so if you think about 1980 as the first open source license, software license, that was 40 years ago. We're there, right? It's only been 9 years since we've had an open hardware license, a true open hardware license. That, where will we be in 30 more years from now in the same time frame? Will the entire stack be open? I hope so, because, and I think KiCad plays a prominent role in that, as we'll continue to try to increase the breadth of things you can do it with open tools over time, and that's one of our goals. So whenever you can use an open design, use it. It sends a message to the people who aren't open that you prefer open, because that's what happened with the open source software. Basically, the message was, if we can use open and it suits our needs, well, that's where we're going to go. And so vendors notice that kind of, you know, when their business starts going away. So if you can use open, please do. Okay, now, a lot of things, for those of you who don't follow the project closely, this is just a quick year in review since last FOSDEM. Right after FOSDEM last year, we released 5.1, is the stable release. I got hired to work full-time on KiCad, yay. Well, there's another side to that story. We had the first ever KiCad conference in Chicago in April last year, and if you didn't make that, you missed a great conference. Probably one of the best I've ever been to. So if you have a chance to make it this year, I highly recommend you make it. And I'll talk a little bit more about that later. KiCad Services Corporation was formed this year. One of the dings against KiCad was, well, I can't get paid support for KiCad. Well, now you can. There's commercial. So if you're a corporate user and you just got to pick up a phone and call somebody, you can do that now. And in fairness of open disclosure, I work for KiCad Service. It was formed by Seth, and thankfully he invited me to be part of that. And in October, WIT, the company that promised me that we were going to make KiCad fly, dropped me. So boo. So that didn't last long enough to get anything significant done. Really, it was kind of a bummer. The other thing that happened in November of last year, we joined the Linux Foundation. And now what that means is we have a two-pronged setup for donations. The CERN donations will continue as they always have. But one of the reasons we joined Linux Foundation is CERN has pretty strict rules about how we can spend that money. So really for software development. The Linux Foundation allows us to do things like pay our developers to go give talks. So the Linux Foundation gives us a lot more flexibility how we spend our money. It's not just software development. So if you are interested in donating to Linux through the Linux Foundation, you can just find the links there in my presentation. So I joined KiCad Services in December. We also moved, another big thing that happened, we moved from Launchpad to GitLab, at least just the source for now. Eventually, we're going to try to migrate the whole project there because there's a bunch of stuff at GitHub right now. But I'm really happy. This move's worked out really well. I'm surprised how easy it was and how much I think it's going to help development, our workflow just a lot better. Yesterday, we had the first ever new KiCad developers meeting. So there was about, 10? 15 people who aren't regular KiCad developers. And three of the lead development team were there, and we introduced them to the code base and helped them work through some pet bugs that they were interested in fixing. So that's significant because it's always nice to be able to bring in new talent into the project. And because the KiCad code base is pretty intimidating, so it's not something that you'd probably want to take up on your own. Now, a couple announcements. KiCon 2020. If you missed last year's, you definitely want to make this year's. It's going to be at CERN in Geneva, Switzerland from September 11th through September 13th. The tickets haven't gone on sale yet, but keep an eye on either the blog post on the KiCad website, or you can go. I have the link right now. It's just a placeholder image file. There's no information, but I suspect the tickets will probably go pretty quickly to this one. So if you're in Europe in September and going to CERN to talk about all things KiCad sounds interesting to you, please come to that conference. The other thing that's happening is Monday and Tuesday and Wednesday of next week, the folks at Eisler, and I'm going to butcher this, Aachen, did I say it right? Aachen, okay. We're going up, there's quite a few members of the lead development team here. We're going to go up for a hackathon for 3 days and work on KiCad. So we get a chance to it's rare when we all get a chance to sit down and work together. It's usually email, and that whole process is less than ideal. And just an announcement about, I put an initial goal. I had no idea what to really put down, so I put $40K down for 1 year at Linux Foundation. We're already about a third of the way there since November. So the donations are good. I thank you for all the time. And so just what I always say thank you to the development team, because I get to stand up here and people know my name by the fact that I'm the project leader, but I'm just one guy of many. It's a big team of people that write source code, develop libraries, documentation, translations, package builders, the whole 9 yards. I mean, there's probably 50, 80 people combined it takes to pull, contributing in their own little special way to make the project work. I always say thanks to our donors. It keeps KiCad going, and it helps it attracts interest to other people who might be interested in developing KiCad. It definitely is a plus. I always say thanks for that. Thank you for your interest in KiCad. We're going to continue to do our best to provide the best possible electronics design application that we can, and I don't see us slowing down anytime soon. It's just going to keep growing and growing and growing. It's getting more feature rich. It's getting more impressive every year. The things you can do with KiCad these days are there's very few limits. I mean, it's not a stripped down 4-layer board layout package. It's a 27-layer 800-pin FPGA monster board layout. One of our users who's like our performance test guy, because he's got some incredibly complex designs. So KiCad can handle something like that. You're probably not. I don't know too many people doing board designs that are more complex than that. And a special thanks to Seth. In Javier's absence, Seth stepped up and did the dev room. So thanks to Seth for stepping up and helping out there. So thank you. So, all right.
So maybe that's kind of a private question, and I do understand you don't want to answer it, but I remember us sitting in this bar in April, and Jeff was totally excited about all that stuff, and now there are some questions in my mind, whether this was more a personal thing that didn't work out, or...
If you mean the relationship between myself and Jeff, no, it wasn't that. It was, I'm not at liberty to talk about it because I signed an NDA, so I can't talk about anything WIT company-wise. But it was not my decision. It was based on other factors. You could probably guess. If you were there that night, you can probably guess what happened. So I'm just going to leave it at that.
Okay, yeah.
Please say something about version 6.
I knew somebody was going to ask him. They say something about version 6. That's not really a question, but I'll say something about version 6. Things are starting to roll into the master branch now. I'm working on the new file formats for the symbol libraries and the schematic. And so that should be done here, hopefully not too distant future, because there's a lot of new features that kind of sit on top of that. But there's a lot of work going on. There's some configuration work that's going to change. We're going to start, one of the things I heard somebody earlier complain about, that, that when, that we used to save, or we currently save like some of the visibility states of the layers in the board file. So when you change them, even though you didn't change the board file changes. We're ripping all that out. We're taking that out. So that'll be a separate config file. So we got somebody working on that. So there's a lot of things happening. I mean, it's key features, curve traces, groups and rooms. What else?
Pad stacks.
Yep, pad stacks. We have a layer manager now that's already done. That's been in there for a while. That you can, set layer color. You can set all the definitions of between layers. So there's a layer stack up editor now. You can assign a color, a silkscreen color, a mask color, the thickness between each copper layer. So yeah, there's that. What else are we working on? Anybody? What am I missing, guys?
2581 export.
Yep, 2581 export will be in there. Somebody's actually working on an Altium importer.
Right.
Whether that'll be ready for 6 or not, I can't say. But I mean, it's
Sitting right there.
where is he here?
Yeah.
Is he? Oh, there he is. Yeah. So who knows?
Bus topology stuff.
I'm sorry.
The bus topology stuff. That's
Oh, right. Yeah. John's bus work.
Oh yeah, that's right. There's real time net list management, so the net list will be updated real time as you make changes. So that was done. Yeah, sorry, John. But yeah, it's nice because we have the bus unfolding now. That it's a feature if you create a data bus or an address bus, a complex bus using the standard text definition. You can go and break out, when you right click, you can break out the bus, each net, and it'll automatically connect. It's pretty slick. So some neat stuff going on. There's some people who want to work on orthogonal dragging for the schematic editor, so that the wires stay nice square, right angle lines, instead of when you drag now you got to break them yourself and make them square again. So yeah, there's lots of things going on right now. I know somebody's going to go. The next question is going to be when, and I would say, given the current rate, I'm hoping we're like in a feature freeze in beta around KiCad. We'll have a better idea at KiCad, but I'm hoping we'll be close to that, so that maybe by the end of the year, we're close to a 6.0 release. Yeah.
Yeah, so I just wanted to pick up on the analogy you're making for the software side. So one of the things that helped open source software is it was an easy way for large companies to commoditize the cost of some of the big things they were maintaining, IBM, HP, and whoever else. I can see that's kind of happening on the hardware side for a lot of things, like board design and so on. Where I'm having a hard time figuring that is for the silicon manufacturers. So the fabs themselves, I don't see how open hardware commoditizes their costs. And I was wondering if you could kind of chime in on that.
Well, there's actually, I know now there's actually people working on trying to get an open PDK. So that's work in progress. Those are things that I'm not at liberty to talk about, but I know people are trying to do that. And I think like I said, I think eventually it's kind of the one domino theory. If you can just get that one, even if it's not perfect, and even if but it's, it meets the needs of a large enough group of people, people who want open will start to merge that way, and people will see their, other customers will, or other, fab guys will see their business going elsewhere. And it's kind of how the open source worked. It was there was a first implementation, and people started to go that way, and somebody noticed, hey, where are all these guys going, right? So I suspect that, like I said, I'm not naive enough to believe that it's quite the same as software, because, like I said, the internet makes software cost zero. There's never going to be a zero cost hardware solution.
Is the money spent on the commercial support anyway less effective on code development than
The question is when so for KiCad Services Corporation, if somebody pays for a feature or a specific fix, does that affect it? It doesn't affect the development. It only affects the order in which things get done. Normally, I have like a progression of things I'm working on. So as long as nothing gets in the way of that, that's kind of how I go. But if somebody comes to me and is willing to pay me and say, "Hey, I want this done first," well, I'm not going to say no. You know, I slot that in, and then everything else. But a lot of times it's a feature that it all goes back into KiCad proper, right? So it gets merged into the main KiCad master branch. So I don't see a downside to it. I just don't see a downside. It's not like we're just making those features for like one person and we're hiding it, because you can't do that. The KiCad code base is, excuse me, GPL3, so we're kind of tied to that.
What do you think is the biggest thing holding back KiCad development?
What do I think the biggest thing holding back KiCad development? That's a good question. A lot of it's just time. You know, most of us up until recently are very part-timers. You know, when you have a full-time job and family, and, you know, you want to have at least something that resembles a life, you know, which I didn't for a long time. If my wife was here, she'd tell you that. So, I mean, I think that's just, you know, what it boils down to is if we can get back into some way to monetize it, so we can pay people to work, spend more time just working on KiCad instead of working on it in their spare time. So actually, development pace has picked up in the last couple of years. Most of the lead development team seems to be able to find enough time to spend to get work done. So, I mean, obviously, it'd always be nicer if you could do it faster, but it's actually it's moving along pretty good right now. Any other questions?
Maybe two more questions?
Yep.
Yeah, there's always a trade-off between ease of use and user experience versus the full capabilities of what, you know, a professional user using Cadence or somebody might need. What's your philosophy on that? How do you make that trade-off? Because you don't want to make Fritzing, and you can't make Cadence.
The question is trade-offs between usability and complexity. There's always trade-offs. We try to keep the core features that you would use to do simple board layouts fairly straightforward in KiCad. A lot of the times, if you don't need to use any of the advanced features, you're not necessarily exposed to them. So, like, say you would need to do matched length tracing, you know, tuned length tracing, right? There's some configuration you have to do there. You can't get away from that, because otherwise, there's parametric things you have to set up, and there's no way to avoid the complexity of doing that. But if you're just doing simple 2-layer trace boards and filling some zones, that stuff's all fairly straightforward. I can't imagine, you know, like just to do simple board design layouts. KiCad is like so complex that you can't wrap your head around it. It's fairly straightforward.
One more question?
So, I was not really using KiCad in a recent version, but quite recently there was quite a lot of like transitions made in the code base. Like for some time in the fourth version, I guess, there were some changes in how the libraries are stored, changes in we could have chosen different ways the thing is rendered, and depending on that we had different features. So are all those kind of things already transitioned?
Be super quick.
And you're here right now?
The question was, it's the problem with the symbol libraries, which has always been a problem since the original design of KiCad. And the answer to that is yes. These were the problem is to get from where we were to where we want to go. There was a couple of intermediate transitions, and they were somewhat painful, because one of the things, we always had a bug in the old library lookup that was based on the library ordering. So if you had two symbols or identical symbol names in two different libraries, what mattered was the library ordering. So if you, if you picked the library from the one you thought you got, and you had the library ordering wrong, you got the other symbol, and that was the problem. So the table where you map it to a table, now they're all hard to find. They're absolute. There's no relative to the symbols are, and so we had to get from there to there. The next, in version 6, the symbols will actually be embedded in the schematic like the footprints are on the board. So you won't need any cache library anymore. You'll just pick the schematic up and take it with you. And now you may not be able to, if you don't have the symbols on the other machine, you won't be able to update the symbols that are in the board with the latest versions of the symbols in the library, but you'll still have those. You'll still be able to work on the schematic, open it. It'll be completely portable. That's all part of the new file format stuff that I'm working on.
Okay, thank you.
Yeah, thank you. Yeah. I got to go.